Hey, hey, hey. So, right now, our objective is we're going to be talking about things that are statistically significant, and we're also going to be talking about blocking. So, let's look at our objectives on our cover page. We're going to interpret the meaning of statistically significant in context to an experiment, and we're going to explain the purpose of blocking in an experiment. So, let's get started. Hey, hey. Okay, now, the definition of statistically significant we've spoken of before, but the bottom line here is that we have an observation so large that it could not have occurred or rarely occurs by chance. That is the key. Rarely occurs by chance. Now, a prime example of this would be, I'm buying I love my baked Lay's potato chips, and we know how much air goes in those bags. So if I pick up one bag and there's a lot of air in there, okay, that's not statistically significant. If I pick up a bunch of bags, meaning I have replication, okay, is it statistically significant or not? Well, right now I don't know because I'm going to assume that all those chips came from the same lot. So therefore, the selections that I've taken of those bags as I felt the bags for the air, well, they came from the same lot, so maybe it was just a bad lot. Now, if I were able to go to Frito-Lay and randomly check the bags, and I have a replication, which means a lot of bags that I've checked that that are manufactured throughout the day, and I find that yes, there's a significant amount of air in it, okay, that would be statistically significant. Yes, you guys have a problem. You're putting too much air in our potato chips. Where are our chips? You're taking it away, replacing our chips with air. So that is an idea of what statistical significant is. And we're going to get more in depth in that when we talk about null hypothesis and alternative hypothesis, which means that the company says, in reference to what I just said, nope, there's nothing wrong with our bag of chips. They are what we say. That's their hypothesis. Our alternative hypothesis is, nope, it might weigh as much, it might feel like it's as much, but the reality is, no, I shake it around, I don't hear as much chips in there, so therefore, nope, you're cheating us. And going back to the idea of what this means again, here, because I did such a replication and because I did randomize it, meaning I went to the company and checked throughout the course of the day, that was my randomization, it was not likely to have occurred by chance. So, something wrong with your company, you're cheating us. No, just kidding. I don't know if they are or not. So, let's go with our next objective, blocking. So, as I'm looking at the idea of blocking here, what is a block? Well, a block, it is similar to a strata, but. Stratas deal with experiments only. But what a block does here is it breaks it into a subgroup, and this is before an experiment starts. And the subgroups must be similar, but we expect to see a different response in the treatment. So, let me explain this another way. Okay, if I am collecting a survey, it's a strata if I go males versus females. But when I'm doing an experiment, it is a block. So my one block is going to be males, the other block is going to be females. So that's why I'm saying here, we're going to break them into blocks before the experiment starts, into subgroups, male and females. They must be similar. Well, they're genders. And we are expecting to see a difference in the treatments. So if I'm talking about diet programs, seriously, guys lose weight faster than ladies. So I'm expecting to see a difference in the blocks, the male blocks versus the female blocks, in the response to how their weight loss will occur. So that's the best example I can give you for a block. And when it comes to the block, what is a randomized block design? So first of all, let me tell you what it's not. Blocks are not random treatments. They are random assignments of So here, so let me say it again. The blocks are not random. I'm sorry. Say it again. The blocks are not random, but the treatments are random. Okay, so here, let me give you an example. If I have my male and my female, those are my blocks. And then after I've gotten my male and my female and put them in blocks, I'm going to randomly determine, well, who's going to get treatment 1, who's going to get treatment 2, okay, and of the females, who's going to get treatment 1 and who's going to get treatment 2. Okay, that is how you randomly assign within the blocks. So again, it's not that the blocks are random. The blocks have commonality. The blocks are subgroup. They have something similar. In this case, they're genders. But after I have broken them into blocks, I'm going to randomly allocate or randomly assign the treatment within each block. Sorry for the sniffles. Now, next, how should you choose which variable to block? Well, here the best blocking variables are those that give the strongest association within the response variables. So which is going to give us the best predictor of the response variable. So let's go back to that exercise program with the guys. When it comes to the guys, we know that we are expecting that guys are going to lose weight faster than girls. Well, that's why I would have chose those type of blocks. I wouldn't have blocked on ethnicity. I wouldn't have blocked on religion. What is the point of that? I wouldn't have even blocked on looking at if they were just high school students, freshmen, sophomores, juniors, and seniors. I would have blocked on genders because here they have the best variable, they have the strongest association for what I am looking for to best predict the response that I'm looking for, which is the actual weight loss. Something else that I wanted to mention that I didn't mention up here, what is a randomized block design? Not only does it randomly allocate or assign the treatment, it helps us to account for the variation or the reduction of the variability within each block. So I've got my males, I've got my females. A male is a block. So here, after I have my males, then I'm going to randomly assign the treatment 1 and then treatment 2. So that's going to reduce variability. But let's face it, isn't that what randomization does all the time? It reduces variability. Isn't that the whole reason behind it? Yes, it is. So let's do some examples. Turn to page 16 of your notes. And let's go ahead and read this. So we're looking at different type of cancers and 3 different therapies, and you can see what we've recruited here: 500 males and 300 females. Okay, so we've read that, and we're asking which are the blocks. Well, the blocks are the genders, so the sexes. Next question is why, or what are the advantages of the randomized blocks over the completely random design of 800 subjects? Well, here, remember what the blocks do. They allow us to determine, to account for, or to take out or minimize the variability based on the different genders. You put the men and the women together and then you give the treatments, then how do you really know, or how do you differentiate how the treatment did better for men versus women? The bottom line is, if you did it like that, you still have to go back and look at the genders somehow. Or do you just say, well, 20% of the people this therapy worked for, the other 20% therapy B worked for. But the problem is, without the blocking, women and men react differently, so therefore their bodies are going to react differently to the therapy, and it is going to cause a lot of, let's say, again, the word variability within each individual treatment. So treatment B might be lower than it should be because you have women in there that don't work well with that therapy. Treatment C might be might have completely different effect. Why? Because you have more men in that therapy. So you've got to do the separation of the genders. Okay, the next question is, suppose that the researcher had 800 males and no females. Okay, so the problem with this one is the advantage. So what advantage would it offer? Well, I spoke of the disadvantage first. There's no variability in the response given one gender. There is your disadvantage. But our advantage is we will be able to determine which treatment is best for that particular gender, the men. So, let's see what's next. Okay, so after looking over things, I'm almost out of here. So I want you guys to do finish up page 16 of your notes. So go ahead and do problem 78 and be ready to discuss things on Monday. Have a good weekend. Bye-bye.